Karthik. I'm currently studying second year MBBS at AIIMS Nagpur. I had secured 680 marks uh, in in NEET examination 2 years ago, and I had the All India ranking of 878. So today we're gonna see some questions PYQs of the chapter the D and F block elements. So let me start with the first question. So the first question is identify the incorrect statement. So option one, they are given as the transition metal and their compounds are known for the catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. We know that transition metals, mainly the D block. Let us consider D block. They have configuration of argon 4s1 or 2 and 3d 1 to 10. This is the configuration the D block elements have. So the this is the D shell, this is the S shell, this is 3D shell, this is 4S shell. The thus there are 10 elements. They will be having electrons in these. They will be having electrons in these shells. So because of and we can remove all these electrons. They will be having the electron. This is a complete configuration. So if you consider any half configuration, let us say this is the configuration which you present. So in this one, we can remove this electron, this. So there is a possibility of many oxidation states. Possibility of many oxidation states. Many oxidation states. So as there are many oxidation states, they can perform many reactions. So they can they can catalyze they can do many catalytic activity. They can perform in many reactions. So the first statement is a correct statement. So they have asked about the incorrect statement. So option A is a correct statement. So option B, interstitial compounds are those that are formed when small atoms like H, hydrogen, carbon, or nitrogen are trapped inside the crystal lattices of metals. This is also a correct statement. Next, the oxidation states of chromium in CrO42 minus and Cr2O72 minus are not the same. And option D is Cr plus 2, which is D4, is a stronger reducing agent than Fe plus 2, D6 in water. So option D is also a correct statement. So option C is an incorrect statement because the oxidation states of chromium in CrO42 minus and Cr2O72 minus are same. Okay, the oxidation state is same. That is the plus 6, which is present in this. So we have to see the structure, and after that we can know this one. Okay. Yeah. Second question. So second question is we have scandium that Sc Z is equal to 21 is a transition element, but Z and Z, zinc, the Z is equal to 30 is not. Because if we want to say, if we want to say any metal, any substance, any element is a transition element. Transition element because any element is a transition element if it has a incomplete D shell. Okay. It should have incomplete D subshell. D is not a shell, it is a subshell. If you say Sc is equal to argon consists of 80 and 4s2 and 3d1. It is incomplete. D is this one. In this D, only one electron is there. So this is incomplete. If you consider zinc, it has argon 18 4s2, 2. Then 10 electrons are remaining. 3d, 10, 10. Okay. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. This is complete. No, this is complete. This is incomplete, and this is complete. As it is complete, it does not it does not match with the statement. It does not match with the definition. Definition is any element is a transition element if it has incomplete d subshell. So in case of SE, 3D orbitals are partially filled, and in case of ZN, these are completely filled. Option C is the correct answer. Okay, option C. A transition element must have incomplete d subshell. Zinc have completely filled D subshell having 3D10 configuration. Hence, they don't show properties of transition elements to any appreciable extent, except for their ability to form complexes. Okay? So let us see question number 3. Question number 3 is, which one of the following does not correctly represent the correct order of the property indicated against it? Okay. They have asked which doesn't correctly represent the correct order. So, so titanium, vanadium, chromium, manganese. We know that titanium is 22, vanadium is 23, chromium is 24, and manganese is 25. If we write the configuration of titanium, it will be argon, we know, argon 18, 4s2, 3d2. Vanadium is argon, 4s2, 3d3. Chromium is argon. It is not 4s2, it is 4s1, 3d5. It can it could have been 4s2, 3d4, but this configuration is not so stable as this configuration. This the 4s2 3d4 configuration is not so stable. So the stable configuration will be 4s1 3d5. So chromium will be in that state. Okay. And manganese is argon 4s2 3d5. Okay, this is the manganese. So we can remove all the outermost electrons. Here it can show up to +4. Here it can show up to +5 or 5 oxidation states. Here it can show up to +6. Here it can show up to +7. Is up to +4, up to +5, up to +6, and up to +7. So manganese have 7 oxidation states. It can show 6, it can show 5, and it can show 4. The order is this one. So this order is correct. This is the correct order. Correct order. Option A is the correct order. They have asked about the incorrect order. Okay. This is the correct order. Option B is titanium +3, vanadium +3, chromium +3, increasing magnetic moment. So this is also a correct order. The +3 of titanium will be having only 1 electron. +3 of vanadium will be having 2 electrons. +3 of chromium will be having 3 electrons. And +3 of manganese will be having 4 electrons. So magnetic moment increases. So next is the option C is titanium, vanadium, chromium, manganese, increasing melting point. This is a correct statement because the positive power, the positive power or the protons and electrons are increasing. The positive power increasing. As the positive power increasing, it will attract electrons towards itself. Attract electron towards itself. Towards itself. Attract the electron towards itself. Because of that one, The melting power increases. Understand? Melting power, melting not power, it is melting point. The melting point increase. So option D is melting power increases. This statement is not a correct statement. Okay, they have asked about the answer is this question. This is the answer. This is the incorrect statement. Okay, sorry. This is the incorrect statement which is present here. Okay, sorry. So titanium, vanadium, chromium, manganese, increasing melting point. This is an incorrect statement. We need to see the uh, chart for this one. Okay, it is given in NCERT, so we can see there. So option D is uh, titanium, vanadium, manganese, chromium, increasing second ionization enthalpy. Second ionization enthalpy we need to compare here. So it is a correct statement. So we have already got the answer. That is the melting points of the transition element first rise to a maximum and then falls as the atomic number increases. So there are 10 elements which are present. So first it will rise from here to here. It will rise. After that it will fall. Okay. It is a chart which is given in the NCERT. So we need to see that one. Option C is the correct answer. Next, there are four successive members of the first series of the transition metals are listed below, for which one of them, the standard potential E naught of m plus 2 to m value has a positive sign. So here also we need to see the table which is given. So the answer here is copper. Okay, the copper will be having E naught of copper plus 2 to copper will be having 0.34 volts plus. So the standard reduction potential, it is a positive value. Others will be having negative value. Okay, it is a positive value. So which of the following oxidation state is the most common amongst the lanthanoids? So the question they have asked about the lanthanoid series. Okay, um, we know that lanthanoids, lanthanoids most commonly show plus three oxidation state. So plus three oxidation state most commonly. Okay, they can also show plus two and plus four state. So plus four states in case of if there is if there is half filled D, yeah, fully filled D configuration. Okay, if there is half filled D configuration, yeah, fully filled D configuration. So lanthanoids, the general equation for lanthanoids is general electronic configuration 4F N 5D M 6S2. This is the general electronic configuration. Okay, where N varies from where N is equal to N varies from 1 to 14 and M varies from 0 to 1. It can be 0 or it can be 1. So N, it can be 1, 2, 3, 4, up to 14. Okay. Yeah. Hmm. So this is about the lanthanodes. So lanthanodes most commonly show plus 3 oxidation state. This is a statement which is present in NCERT. And after that, it can also show plus 2 or plus 4 oxidation state. If there is the chances of getting half filled D orbitals, D subshell, yeah, fully filled D subshell. because we know that half filled and fully filled D, or which the D subshell is more stable. So it will attain that configuration instead of plus 2. So here the option is option A. Answer is option A. Plus 2 oxidation state is the most common for the lanthanodes, but occasionally plus 2 and plus 4 states are also obtained due to extra stability of the empty, half-filled, or fully filled F subshell. Sorry, it is not D, it is F. Okay, F subshell. Next, which one of the elements with the following outer orbital configurations may exhibit largest number of oxidation states? It is a simple question. Yeah, it's a simple question. The question it is 3D5 4S1 and 3D5 4S2, 3D2 4S2, and 3D3 4S2. Here we can remove one electron up to six electrons. Okay. So plus one, plus two, plus three, plus four, plus five, plus six. Total one, two, three, four, six oxidation states are there. Here we can remove some electrons. So seven oxidation states are there. Here we can remove four electrons. So four oxidation states are there. Here we can remove five electrons. So five oxidation states are there. So option is the correct answer is option B. Option B. That is 3D5 4S2. This is the configuration of manganese. Okay, manganese. It can exhibit from plus one up to plus seven. So seven oxidation states. Because of this property, they can catalyze many reactions. Okay? So they have a very they can act as cofactors in many enzymatic reactions. Next, match the catalyst with the process. Match the catalyst with the process. There is a problem in the question, so I will directly give you the answer. Okay, the question is incomplete here. So the oxidation, the answer is so I will explain the directly the answer. So we know that in the oxidation of SO2, in the oxidation of SO2, in the process of manufacturing of H2SO4, SO2 oxidation in H2SO4 H2SO4 manufacturing, we use V2O5. V2O5 is used, and TiCl4 plus AlCH3 whole thread is used in the polymerization of ethylene, and PdCl2 used in the oxidation of ethine to ethanol, and nickel complexes are used in the polymerization of alkynes. Okay, this is the answer for this question. There is a problem in the question. So this is a theoretical question. We need to know the theory and statistic. So the next question is out of TiF6 2 minus, COF6 3 minus, and Cu2Cl2 and NiCl2 minus. So the colorless species are the colorless species are. So let us write the configuration. Okay. So in the case of TiF6 2 minus, what is the oxidation state of the titanium? What is the oxidation state of the titanium? Okay, we need to see that one. So oxidation state of titanium plus this one should be -2. Okay, oxidation state of titanium is X, and of the fluorine will be -1, that is -6. Six fluorines are there, -2. So X is present in -2 plus, so it is present in the +4 oxidation state. The oxidation state of titanium here is plus 4 plus 4 oxidation state. So we know the titanium is 22. Titanium is 22. So 22 is argon. Argon is after them this one. Yeah. Hmm. So argon has 18 and titanium is 22. So 4 is 2. 4 is to 20 and 1 2. This is the this is the electronic configuration of titanium. So if it is titanium plus 4, then there will be no electrons. And then, so there won't be this electron, there won't be this electron, there will be this one. So it will be plus 4. So there are no electrons. No electrons. So colorless. So colorless. So if you consider next one, that is COF63 minus. COF63 minus, the oxidation state of cobalt will be X plus minus 6 is equal to minus 3. So X is equal to minus 3 plus 6, it is plus 3 state. So the cobalt is present in a plus 3 state. So, and we know cobalt will be having, after the plus 3, it will be having 3D5 configuration. 3D5 configuration. 3D 3D5 configuration it will be having. So 3D5 configuration matlab 1, 2, 3, 4, 5. So there are presence of this unpaired electron. The presence of these unpaired electrons are present, and these electrons can go from here to this electron can jump here, can jump here, can jump here, can jump here. This is known as DD transition. DD transition. It can undergo 3D transition. There is a presence of these electrons, so it is a colored compound. So it is a colored compound. And next one is Cu2Cl2. Cu2Cl2. In case of Cu2Cl2, the copper is present in plus 1 oxidation state. Cl is minus 1. So minus 1 total is minus 2. It is also there are two x plus y should be equal to 0. X is equal to 2x plus 2y is equal to 0. Okay. There are two coppers. 2x plus 2y should be equal to 0. Huh? So 2x is equal to 2 into minus 1 is equal to 0. So 2x is equal to 2. So x is equal to 1. So copper is presenting plus 1 oxidation state. If the copper is presenting plus 1 oxidation state, there will be 3D10 configuration will be there in copper. So as a 3D10 configuration is there, there is no unpaired electron. No unpaired electron. 1, 2, 3, 4, 5, 7, 8, 10. So 3D10 configuration is there. No unpaired electron. No unpaired electron. No color. There is no DD transition. So colorless. So it is colorless. So next they have given Ni, nickel, NiCl2. So NiCl2 minus nickel is present in the oxidation state of, so X plus 4 into minus 1 is equal to minus 2. X is equal to plus 2. Okay. Nickel is present in plus 2 oxidation state. When it is in the plus 2 oxidation state, nickel will be having 3D8 configuration. 3D8 configuration, it is 1, 2. So there are two unpaired electrons. There are two unpaired electrons. As there are two unpaired electrons, they can undergo DD transition. They can undergo DD transition. DD transition. So it is colored. So it is colored. Okay. So the colorless we have TiF6 2 minus and Cu2 Cl2. So option B is the correct answer. Okay. So they have given that the color exhibited by transition metal ions is due to the presence of unpaired electrons in d orbitals, which permits the dd excitation of electrons. dd excitation of electrons. Okay. So you can ask why in Cu2 Cl2. So I will explain about copper now. So copper, you know that the copper, the Z is equal to 29. So argon is 18, 4s to 2, and 3d 9. 9. As per as per the law, it should be like this. Okay. As per we know, as per the general knowledge, common sense. So it should be like this. But in copper, it is not like this. In copper, the configuration is not like this. Configuration is 4s1 and 3d10. Here it is 1 and here it is 10. Because the 3d9 is not a complete shell. Not a complete shell. And 3d10 is a complete shell. It's a complete shell, complete subshell. Okay, complete shell. So it has more stability. Has more stability. So it has more stability. So when we remove one electron from copper, that is Cu plus, the electron which will be removed is the 4s1 electron is removed. 4s1 electron removed. So the configuration of Cu plus will be at the end, it will be 3d10. The argon and 3d10. This is the configuration will be there. So it is colorless. Okay. So it is colorless. You can say we know that generally copper exists in Cu plus 2 state. The copper exists in Cu plus 2 state in the copper exists in Cu plus 2 state. We know that Cu plus 2 it will exist. So it should be like the Cu plus 2 state should be more stable than that of the Cu plus state. The Cu plus state there we have 3d10 configuration. In Cu plus 2 state we'll be having argon 3d9 configuration. Argon 3d9 configuration. But we know that copper always exists in usual exists Cu plus 2 state. And this one happens only in solution. This one always happens in solution. Okay. In solution, it will be present in Cu plus 2 because of the high hydration energy. Because of high hydration energy. Because of high amount of hydration energy. Why there is a high amount of hydration energy? The Cu plus 2 has a smaller size than that of the Cu plus, as it contains 2 electrons less than Cu plus. So due to its small size, the charge of the ion remains concentrated and is not spread widely. So because of this, due to this accumulation of charge, the polar water molecules can easily make bonds with the Cu plus 2. The Cu plus 2 will be smaller than that of Cu plus. So it will be having high charge density. High charge density. Because of this, it attract more water molecule. Attract more amount of water molecules. As it attract more amount of water molecules, there will be high amount of hydration. There will be formation of bond. So hydration energy is more. So the so the stability of the Cu plus 2 is more than that of the Cu plus in the water in the solution, as the stability depends upon the hydration energy of the ions when they bond to the water molecules. So Cu plus 2 has a greater charge density than that of the Cu plus ion and thus forms much stronger bonds, releasing more amount of energy. So this is some important points about copper. So this is some important points about copper. So so let us see the next question. So the correct order of decreasing second ionization enthalpy is. So Titanium 22. It is argon 4s to 3d2. Vanadium 23, argon 4s to 3d3. Chromium 24, argon 4s to 3d. It is 4s1 3d5. Okay. Same as copper. Because of half-filled d orbital, it will be more stable. Manganese will be 25, argon 4s to 3d. 5. So if you consider titanium plus will be having argon 3d2 4s1. Okay, will be 3d2 4s1. So if you consider vanadium plus 1, it will be argon. So in case of vanadium plus, it will be 3d3 4s1. In case of chromium plus 1, it will be argon 3d5 4s0. In case of manganese plus 1, it will be argon 3d5 4s1. Okay, it is the electronic configuration of first ionization enthalpy. So they have asked about the correct order of the decreasing second ionization enthalpy. Decreasing second ionization enthalpy. If we excite or if we remove one more electron from the titanium plus 1, so if it is titanium plus 2, this electron is removed. This one is removed. This one will be removed. Okay. If it is vanadium plus 2, then it will be this electron will be removed. 4s1. This electron will be removed. If it is chromium plus 2, so then the electron which is removed will be from half filled, then it will be 3d4 it will have. So the electron is removed in Cr plus 2, electron is removed from half filled d subshell. So this is the half filled d subshell. So from this the electron is removed. So in order to, and we know that half filled d subshell is very stable. Half filled d subshell is very stable. So we know that this is stable. So we are removing an electron from that half-filled d subshell. So there will be loss of stability. There will be loss of stability. As there is a loss of stability, we need to give more energy. So in order to remove that electron, more energy is required. In order to remove that electron, more energy is required. Because we know that all the elements want to be in a stabilized state, not in an unstable state. So already that element is present in a stabilized state. Okay. So if you remove the second electron, it will undergo instability. So we need more energy to make it. So option A is the correct answer. Option A. In option A is only the chromium is present first. So chromium will be having the maximum. So option A is the correct answer. By saying that, we can say that. Okay. So this is the answer. So the second electrons in all the cases except chromium is taken out from the 4s orbital, and for the chromium it is taken from the half-filled 3d orbital. The force required for removal of the second electron will be more for manganese than others due to having a more positive charge. So in case of all the others, in case of in case of all others, so the manganese, in case of titanium, vanadium, and manganese, the manganese will be having more because it has high positive charge. Because of that, there will be more attraction. After that, there will be vanadium because it has more positive charge than for titanium because there are 23 protons are there, and in titanium there is only 22 protons, so it will be least. Okay, so chromium greater than manganese, greater than vanadium, greater than titanium. This is the answer. Okay, so next question is. So the next question is, which one of the following ions is the most stable in the aqueous solution? Which one of the following ion is the most stable in the aqueous solution? So if you consider vanadium 3, so you consider vanadium 3, we know that 23. So vanadium plus 3 will be, it will be argon 4s2 3d3. So titanium plus 3 will be only titanium. Titanium, argon 4s2 3d2. Manganese, argon 4s2 3d5, and chromium, argon 4s1 3d5. So if it is vanadium plus 3, vanadium plus 3, so vanadium plus 3 will be having these two electrons will be removed and this one electron will be removed. So it will be 3d2 configuration will be there. And titanium plus 3, titanium plus 3, it will be having d1, 4s2 is removed, and here it is one electron is removed. One electron is removed. So it will run 3d1. In manganese, 4s2 is removed, and here it is one electron. So 3d4 is removed. 3d4 it will be there. Okay, manganese will be 3d4. And in chromium, one electron is removed here, and two electrons are removed here. Two electrons are removed here. So it will be 3d3 configuration will be there. So we know that according to crystal field theory, according to crystal field theory, according to crystal field theory, what is crystal field theory? So, according to uh, crystal field theory, we know that there is a splitting of the d orbitals will be there. Splitting of the d orbitals. We know that usually the d orbitals are like this. Okay, this is the d orbitals. So according to crystal field theory, there is splitting of these d orbitals. There will be splitting. So splitting in the octahedral configuration. The splitting is different for octahedral and that of the tetrahedral. We are seeing the octahedral configuration splitting. Octahedral configuration splitting. There will be presence of two. There will be presence of, here it is 5. So this 5 gets divides into 2 and 3. So this will be a lower energy than the high energy. Okay, so in the high energy, this will be having the low energy. So here, in the case of chromium, there are 3 electrons are left. There are 3 electrons are left. So it is a complete, this complete club half filled. This is half filled. So it will be having more stability. So more stability. So more stability will be there. Okay. So to consider any other like vanadium. Vanadium has 3d2. So 3d2, there will be only 2 electrons. There will be only 2 electrons. There will be only 2 electrons will be present here. Okay. In the case of vanadium. In the case of titanium, only one will be present. Only one will be present. So in the case of manganese, there are four electrons will be present. One, two, three, and four. Like this, it will be for the manganese. Okay. And in the case of chromium, it is the um, diagram which I have written. So chromium plus 3 will be most stable in aqueous solution according to crystal field theory because it has T3 2G configuration. Okay, which is the most stable among the given options. Hmm, okay, so next question. So the next question is, in which of the following pairs are both the ions colored in aqueous solution? Okay, so in which of the following pairs both the ions are colored? So we know that SC, which is 21, there will be 4s to 3d1. Titanium, it is 22. That is titanium, which is 22. That is 4s to 3d2. Nickel, 28. That is 4s to 3d8. And it is next it is cobalt, which is 27. That is 4s to 3d7. So they are doing Sc plus 3. And then plus 3, there will be only argon configuration will be there. Okay. If it is titanium plus 3, there will be 4 is 0, 3D, 1 configuration will be there. Okay. In the case of uh, cobalt plus 2, in the case of cobalt plus 2, there will be 3D7 configuration. 3D7 configuration will be there. In the case of nickel plus 2, there will be 3D8 configuration will be there. In the case of copper, in the case of copper plus 1, there will be 3D10 configuration will be there. Okay. In the case of nickel plus 3, there will be 3D7 configuration. And in the case of titanium plus 3, we already know we'll be having 3D1 configuration. So they have asked about, uh, so in the case of SSC plus 3, there is no unpaired electron. No unpaired electron. No unpaired electron which are free. Okay, there is no free electron. In the case of titanium, uh, in the case of titanium plus, there is unpaired. There is one unpaired electron. Okay. In the case of nickel plus 2 and nickel plus 3, in nickel plus 2, there is two unpaired electron. Two unpaired electron is present. Okay. In the case of nickel plus 3, also there is unpaired electron. In the case of plus 3, we know that there is an unpaired electron. In the case of cobalt plus 2, there is three unpaired electron. Three unpaired electron. How cobalt plus 3 is cobalt plus 3. Cobalt will be 1. Cobalt plus 3 is 7. That is 1, 1, 2, 3, 4, 5, 6, 7. These three are unpaired. These three are unpaired electron. These three are unpaired electron. So there are unpaired electron. So in order to give rise to color, in order to give rise to in which of the following pairs are both the ions are colored in aqueous solution, and both the ions are colored in aqueous solution. In order to give the color for color, unpaired electron should be there. Unpaired electron should be there. Should be there. Because so when we can say the color is produced, the color is produced when electron goes from one uh, subshell to another subshell like this. Is the here there is a transition. These unpaired electron then go under the transition. Okay, because of that the color is produced. So here there are three unpaired electron in the cobalt cluster, so the color is produced. Because of these unpaired electron, the color is produced. So the option D is the correct answer. where nickel and titanium both have unpaired electrons. Okay? So in option 1, Sc plus 3 is there which has non-paired electron. Option B, Sc plus 3 which has non-paired electron. In option C, Cu plus is there which has non-paired electron. Option D is Ni plus 2 and Di plus 3 both have the unpaired electron. So option D is the correct answer. And produce the color. Okay. So next question is the aqueous solution containing which of the following ions will be colorless? The aqueous solution containing which of the following will be colorless? We already know Sc plus 3, no unpaired electron. This should be the answer. Sc plus 3, no unpaired electron. So Sc plus 3, no unpaired electron. If Ti plus 3, we know that titanium plus 3, there is one unpaired electron. One unpaired electron. So manganese plus 2, there are 5 unpaired electrons. And Fe plus 2, there will be 5 unpaired electron. Okay. So in the Sc plus 3, there is no unpaired electron. So there will be no color. Sc plus 3 is the answer. So they given it like this. Hmm. So the aqueous solution of the Sc plus 3 will be having no unpaired electron. So it is the answer. Okay. So next question. Four successive members of the first row transition elements are listed below with their atomic numbers. Which one of them is expected to have the highest third ionization enthalpy? So we know that Z is equal to 23. It will be having 4s2 3d T. So chromium 24, it will be having 4s1 3d 5 configuration. So manganese will be having Z is equal to 25, that is 4s2 3d 5 configuration. And iron 26, that is 4s2 3d 6 configuration. So let us see about the, so let us see Z, that is vanadium plus 2 state. They have asked about the highest third ionization energy. So let's see plus 2 state. The plus 2 state of vanadium will be having 3d3. Okay. And plus 2 state of chromium will be having 3d4 electronic configuration. The plus 2 state of manganese will be having 3d5 electronic configuration. And plus 2 state of iron will be having uh, 3d6 electronic configuration. So 3d3 electronic configuration is this one. 3d4 is this one. 3d5 is this one. And 3d6 is this one. Okay. So it is easy to remove an electron from here. It is easy to remove an electron from here. It is also easy to remove from here. It is also easy to remove from here. So in the case of manganese, there is half-filled d orbitals. There is half-filled d orbital. Half-filled d orbital is, as there is half-filled d orbital, it will be more stable. Half-filled, incomplete, and fully filled. Fully filled d orbitals have more stability. So here there is half-filled. So here there is half-filled, half-filled d orbital in case of manganese. In case of manganese. So removal of third electron is difficult compared to others. Removal of third electron is difficult compared to others. So option C, that is the manganese, is the correct answer. Option C, that is the manganese, is the correct answer. So question number 14. Among the following series of transition metal ions, the one where all the metal ions that is a 3d2 electronic configuration is. Okay. Among the following series of transition metal ions, the one where all the metals have the 3d2 configuration is titanium plus, let's see, titanium 22, titanium plus 3 will be having 3d1. Titanium plus 3 will be having 3d1. So vanadium plus 2, that is vanadium is 23. Vanadium plus 2 will be having 3d3. And so chromium plus 3, first option. Chromium plus 3, chromium is 4s1 3d5. The plus 3 will be having 3d3 electronic configuration. And Mn plus 4. Mn plus 4. Okay. Mn plus 4. It is 4s2 3d5 plus 4 is the 2 electrons are removed here and 1 electron and the 2 electrons are removed here. It will be 3d 3 electron configuration. This is not the answer. So option B they have given option B they have given titanium plus. Titanium plus from the 22 1 electron is removed, that is it will be having 4s1 and 3d um, titanium it will be having 4s2 3d2. This is the configuration. It will be having 4s1 3d2. Okay, 3d2 is there. In the case of vanadium plus 4, vanadium is 23. That is 4s2 3d3. In the case of vanadium plus 4, 2 electrons are removed from here. 2 electrons are removed from it. It will be having 3d1. So it is not the option B is not the answer. In the case of option C, titanium plus 4 is given. Titanium plus 4. Titanium plus 4, it is 22. 22, that is 4s2 3d2 and plus 4 is 2 electron 2 electron. There will be 3d 0 configuration. So this is not the answer. In the case of option D, it is given titanium plus 2. Option D should be the answer. Simply all the three options are not the answer, then there will be option D will be the answer. Simple, Sivan. So titanium plus 2 will be having 3d2 configuration, then vanadium plus 3 will be having 3d2 configuration, then chromium plus 4 will be having 3d2 configuration, and then manganese plus 4 will be having 3d2 configuration, and then so this is the answer. Option D. Option D is the correct answer. So just write the electronic configuration, then take the plus 1, plus 2, plus 3, plus 4 steps and eliminate the answer. Okay. Simple. I have done it fastly here, but I have already explained the concept. So next is question number 15. The basic character of the transition metal monooxides follows the order. The basic character follows the order. Okay. So in the periodic table, this is the periodic table. Simply write the periodic table. This is the periodic table. In here, there will be presence of the metals, and here there are presence of non-metal. Okay. So we know that metal oxides are basic, and non-metal oxides are acidic. Okay. Metal oxides are basic and non-metal oxides are acidic. So here there are basic oxides. So here there are basic oxides. So here there is acidic oxides. Okay. So as we move from left to right, the metallic character is decreasing. Metallic character is decreasing, and basicity of the basic nature of the oxide is decreasing. Basic nature of the oxide is decreasing. So we need to see from here. So we know that titanium comes first. Titanium, vanadium, chromium, iron. Like this it comes. So as you move from here to here, the basic nature of oxides basic nature of oxide, obviously it will decrease. So titanium oxide is the most basic. Titanium oxide is most basic. After that, vanadium oxide, after that, chromium oxide, after that, Fe. This is the order. Because we know that at the left side, the metallic character is more, and at the right side, the non-metallic character is more. And the metallic oxides are basic, and the non-metal oxides are acidic. So as we move from metallic side to non-metallic side, the basic nature of the oxides decreases, and the acidic nature of the oxide increases. Okay, so this is the answer. So next one is question number 16. Which one of the following characters of the transition metal is associated with the catalytic activity? I've already said the transition metals, the activity which is responsible for the catalytic activity is a variable oxidation state. As they have variable oxidation states, they can undergo many reactions, they can perform many reactions, they can act as a cofactor for the many reactions. So their catalytic activity is more increased. Okay. So variable oxidation state is the answer. Option A. Next, one of the following shows maximum number of oxidation states. Maximum number of oxidation states is a CR. Here it will be having 24, 3D, 5, 4s1 configuration. Fe, which is 26, that is 3D, 6, 4s2 configuration. And manganese, that is manganese, that is 25, it is a 4s2, 3D, 5 configuration. And vanadium, that is 23, 4s2, 3D, configuration. No? So here it can show 1 plus 6 oxidation states. Here it can show 2 plus it isn't 1 is 1 pair electron is there. 1 paired electron is there. So it won't show all the states. So it will be showing 4 plus 2 maximum of the 6 electronic configuration state. And here it will show 5 plus 2, that is a 7 oxidation states, not electron. 7 oxidation states. And it will be showing 5 oxidation states. Okay, so manganese can show highest number of oxidation states as it has highest number of unpaired electrons. Okay, so this is the answer. In Fe, we have like this. It will be like this. Here it is a paired electron. It is very difficult to remove. Very difficult. So unpaired electrons are removed easily. So this is the answer. So manganese is the answer here. So which one of the following ions exhibit DD transition? So So the next question is, which one of the following ion exhibits the DD transition and paramagnetism as well? So in the first option, the chromium is present in the plus 6 oxidation state. The second option as a chromium is present in plus 6 oxidation state. The third one, the manganese, is present in plus 6 oxidation state. And in the fourth one, the manganese is present in plus 7 oxidation state. For third one, we can x plus 4 into minus 2 is equal to minus 2. X is equal to minus 2 plus 8. It is equal to plus 6. Like this, we can calculate here x plus 4 in oxygen is present in minus 2 is equal to minus 1. X is equal to minus 1 plus 8, that is equal to plus 7 of the fourth place. MnO4 minus. MnO4 minus. It is MnO4 2 minus. So for the chromium, the structure of the chromium should be have to be seen. So because of that, we can say that the both are present in the plus 6 state. So we know this. So chromium plus 6 is chromium. We know there will be 3D uh, 5, 4 is 1. Like this, it will be there. So in the plus 6 state of the chromium, it will be there will be no electrons. So it will be diamagnetic in nature. It will be diamagnetic in nature. So it will be also in diamagnetic nature. Diamagnetic in nature. Plus 7 state of manganese, there will be no electrons. There will be no unpaired electrons. So it will be diamagnetic in nature. So in the case of manganese plus 6, there will be one unpaired electron left. One unpaired electron is left. So it will be paramagnetic in nature. Okay, it will be paramagnetic in nature. So it is in paramagnetic, and there are one unpaired electron is left. This can change from here to here, here to here, here to here, and here to here. This is known as a DD transition. DD transition. So it can also show DD transition as well. So option, so MnO4 2 minus, that is manganese which is present in the plus 6, is the uh, plus 6. That is the correct answer. Option C is the correct answer. Okay, where the manganese is presenting plus 6 oxidation state. That is the correct answer. So, we have completed till 18 questions. So this is for today, guys. So thank you.